Okay, we're dealing with the first portion, the first page of the post-test preview today. And like I said, this is going to basically be in a mirror image outline of what the actual post-test is going to look like. So we're going way back here, like way back to January. Equations 1 and 2 use the following functions. So we got f of x, we got g of x. Find f of x minus g of x. And all that means is that you take your f of x and subtract your g of x. Now, I'm not going to leave it this way because I can still simplify some stuff. So that minus is basically like distributing a negative through here. So it doesn't mess with the first part at all. But here, it'll change signs on both of these values. Now, if I got here, I'm close, but I notice I've still got some like terms. So I got one step left I'm going to go to here. Normally, when we're writing, we write the largest degree first, then the next part, and then 7 plus 3 is 10. Nothing else that goes together. That's it. Okay, you're set and you're ready to go. Then the one that seemed to give us some trouble. Okay, find f of g of 4. When we're doing this, we're starting with the number in parentheses, and we're working backwards. So my first step here would be to find g of 4. In other words, here's my g function. I'm going to plug 4 in for x. So 4 squared minus 3. 4 squared is 16, minus 3 is 13. But that's not the answer, because now I have one more step where I plug that answer into f. So I'm just working to the left. So I'm going to do f of 13, which just means I'm going to stick my 13 in here for x in that portion. So 26 plus 7 is 33. That would be f of g of 4. But you're always working from the inside out or right to left when you're doing those. Okay, so there's basically the first two questions. Identify the transformations from the original log for the following graph. In other words, up, down, left, right. So reminders again. Whatever's in the parentheses is my left and right. Whatever's on the end is my up and down. And so if I can keep that straight, okay, so negative in the parentheses would be right. So right 1. And negative outside the parentheses is going to be down 6. So just directions. You can't just say 1 and 6. You got to let me know what direction you're going with each, so I know you've got that part of the concept. Okay, any place within this post-test where there's a formula needed, the formula will be given to you. In a country with a desire to be more green, gas prices are rising exponentially at a rate of 28.4%. If the average gallon of gas cost $2.70 in 2019, and this growth continues, create a function that models the exponential growth of gas prices starting in 2019. Okay, so A is my starting value, which would be the $2.70. Now I got to decide if I'm using plus or minus, okay? How do I figure that? I see some words that should help me with that. Rising, growth, things like that means it's going up, so plus. And then for my rate, I don't want to put in 28.4 because that would be like 284%. It may feel like gas prices are going up that much, but it's not in actuality what's going on. So if you're not sure how to turn this into a decimal, you can always divide any percentage by 100 and then just use the decimal that you get. So 0.284. And we don't know how long, so I'm going to make that x. So that's my model. That's the first part. The second part, what would the price of gas a gallon be in 2024? It doesn't mean I stick 2024 in for X. Okay? If we started in 2019, that's my baseline year. That's when X would be 0. So 2024 is 5 years later. So could I put this into y equals and scroll? Sure, but I think personally for me a faster way of doing it would be to just type in what I got. And then when I get to the X, I know what that value is. It's 5. So I'm just going to plug that in. Woof duh. So we'd round to the nearest cent since we're talking about money. Holy moly. So at this rate, we're looking at $9.42 a gallon. Got to get the bicycles out. Okay. So that's it there. Identify the domain and range of the function. Some of you, I think, could do this without even typing it in, but let's take a look. So if I go to y equals, and I type this in, so 2 to the x power, again, x up there, plus 4, and I take a peek at the graph. There's a couple of ways I can figure this out. With growth and decay, my domain is always going to be infinite. It's always going to go forever left and forever right. Okay, that's a no-brainer. The range, though, okay, the range is my y values from bottom to top. So if I'm kind of eyeballing it, I'm like, I don't know. Well, let's look at the chart. Let's look at the second graph here and see if I notice anything. I notice these numbers are getting eerily close to 4. Okay, that's my asymptote here. So bottom to top would be from 4 to infinity, but I have a hint for you. 9 times out of 10, that value that might be sticking at the end, plus or minus whatever it is probably going to be where your range starts. So like if this was -3, it'd probably be -3. If this was 1, that'd probably be 1. So the calculator can tell you, but if you're paying close attention, you can probably see yourself what that would be and get that set that way. Oh, end behavior. Okay, this one I want to see a picture for sure. So we got 2 to the 3 divided by 4. So the x, again, we don't have a fraction button, so we just use divide. Excuse me. So here comes my graph. So reminder, when we're doing end behavior, x is always going forever left and forever right. Okay, this never changes. So again, if we forget other parts, at least if we remember that, we're going to get half credit because we got that part right. So remember, we talked about this before. Negative infinity just means as we're going left. Positive infinity just means as we're going to the right. And f of x is a fancy way of saying y equals. So, as I go to the left on my graph, I keep going up and up and up and up forever towards positive infinity. So what this mathematical lingo here means in English is y goes up, positive infinity, as x goes left. Okay? So am I going up as I go to the left? Yeah. Okay, but I have to use the infinities. I can't just use up, down, left, right. So then as I go to the right, I'm kind of just equaling out here. I'm not going to negative infinity. So I start to look, and I'm scrolling. And I'm like, what value am I getting really close to? 0. So this says y gets really close to 0 as we go to the right. That's a true statement. So we let the visual part help us with that. But this should be our starting guide anytime that we're doing those. All right, let's see what else we got here. The price of a 1957 Ford Thunderbird is modeled by the function below, where T represents the number of years since 1957. Okay, when they give you a year, that is your baseline. That's when T would be 0. What was the value of the car in 2000? Okay. So my baseline year is 1957. This is 2000, which is 43 years later. So now I just let the calculator do the magic for the rest. So let's see. We're talking about money. So we got 27,366.64. And if you just rounded to 67, that's not a big deal. But again, I have to understand that when they give me dates, that's going to be my starting point. Because I wouldn't want you to type in 2000 for T. Oofda, that'd be a lot. Excuse me. Okay. Factor the following expression by grouping. Pair the first pair. Pair the second pair. And then we just look one pair at a time to see what's the greatest common factor I can take out. 4 and 10 are both divisible by 2. It's not necessarily always just the first number. They both have x's. I take the smaller of the two exponents. And then, as we have been talking about for quite a long time, even back then, was to get the stuff inside. Remember, you're just taking each portion of this and you're dividing by what's outside that we found is our greatest common factor. So here, 4 divided by 2 is 2. 3 minus 2, exponents play by their own rules. 3 minus 2 is 1, so I can just put that there. Here, the x squareds cancel. Negative 10 divided by 2 is minus 5, or negative 5. So the goal is now, when I do this again for the second one, that I'm going to get the same set of parentheses. Fingers crossed. So I look at 6 and 15. I play with my calculator. I look at my multiplication chart. I look at something. And my factoring help sheet. And I'm like, I think there's a 3 they have in common. So if I divide each of these by 3, 6x divided by 3 is 2x. Negative 15 divided by 3 is negative 5. And I get what I was looking for. So now that I've done this, my last step to get it into factored form is to take my common terms, put them together in one set of parentheses, and take my common terms and put them together in one. Notice I didn't square it. I didn't say there's 2. That one I just keep. So with grouping, it'll always look like that at the end. Now, as we get into the later portion of tomorrow's, I'm going to have to make you think a little bit and explain a few things, but we'll chat through here. Brianna was asked to show the complete factorization of the following polynomial. Brianna's factorization. You're like, okay. Let me just give you a heads up. Whenever a teacher gives you a question like this, is it completely factored? Did somebody do something wrong? The answer is yes every time, because why would I ask it otherwise? So is this completely factored? It absolutely is not completely factored. So I look and I'm like, well, they both had a 3, okay. There's the smaller variable and an x, well, they did that good. It must be something that's going on in here. And it is, because I'm looking for my factoring help sheet, and of course, wait, right there. Yeah, buddy, maybe. There we go. I notice 25 is a perfect square. So then I look up a little further on my factoring help sheet. And I say, ooh, difference of squares. So this is x. This is 5, which I multiply by itself to get each part. And so now I'm going to follow this pattern. First plus second, first minus second. So 3x first plus second, first minus second. For those of you where, again, difference of squares keeps killing you, I don't know what else to say. I keep telling you it's going to show up. And I keep showing you where to find the pattern if you need it. So you just got to do it. Couple to go. Simplify. If things aren't fractions, make them fractions. If things are plus or minus and don't have parentheses, give them parentheses. And if there is any division, the fraction immediately following it gets flipped. Not everything after it, just the immediate part after. So I look, and I'm going to go fraction by fraction, seeing if I can factor or do anything. Like, well, x you can't do much with. X minus 4, I can't do much with. 2x and 3 do not have anything in common. Divide. Okay, these are flipping. X minus 4 I can't do anything with. But, oh, here it comes again. I'm going to even show it on here again. 4 and 9, difference of squares. Ooh, we better know that or we're going to be in trouble on this. So 2 times x, square each of those gets me 4x. Square 3 to get here. 2x plus 3, 2x minus 3. So that was the only thing that was factorable out of the whole group. And now that we're totally factored, we've flipped our last fraction, now we can start canceling stuff. So whack, 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 whack. What have I got left here? I got this x, and I have this 2x minus 3. And again, this x is bonded in the parentheses. Do not cancel the x's. They are not both single and available. Only one is. And so we get that set. So then we get to the last one. And I have a strategy I'd like to share with you on this one. So error analysis. Describe and correct the error made, fix the mistake, and show the correct work. Unfortunately, I made a printing error and I put the work over here. It was supposed to be over here so we had more room to work, but we're going to make this work. This is just me. At the start of this problem, I am not, where my Post-its go? Oh, they're there. I am not going to even look at what they did because I know they screwed up. So we're just going to ignore that for a minute. So I'm going to look at this and say, okay, LCD help sheet. Again, I don't care if you use this tomorrow either. I'm looking through and I'm like, okay, do I see any coefficients? Do I see any numbers hanging out on their own? No. Do I see any single variables hang out? Yes. Do I see any sets of parentheses? Yes. So there's my LCD. So, with what we've done before, both of my denominators become x plus 3. Okay, whatever this is, because they have to be common for us to add them. And I leave the 4 and the 2 that were already there. They haven't gone anywhere. And now it turns into a comparison game. Whatever I check off, I don't need in the numerator to make my equations balance. But I didn't check off the x. So that gets put in the numerator. Do not cancel yet. Do not cancel. I do the same thing here. The x's are in common. I didn't check off x plus 3. Do not cancel yet. Distribute my 2 through. Important to show all your steps. Some of you ended up with a large number of your points on that test because you were showing me some work. You made a mistake here or there, but everything else was good, so you were good. And remember, I'm not getting rid of my denominator here. Don't do it. Combine like terms. And again, even if this was as far as you got, I'm thrilled. But if you happen to notice at the end, hey, wait a minute, I can take a 6 out of each of those, that's a little bit better. Now, did it let me cancel anything? No. Okay, so that's what I was trying to get to. Now I'll look at theirs, and I'll try and figure out what their brains are thinking, which can be a challenge at times. This is the majority of the points, okay? So I'm looking, I'm like, okay, what did they do? They multiplied this last fraction by 3 over 3. But wait a minute. That would be 3 times x. That's not x plus 3. So what happened to this person was they had the right idea in parts, but right here, this doesn't equal that. They didn't actually get to the common denominator. They just tried to kind of wing it and make sure that was good. Okay? That is day 1 of the test. That's tomorrow, what we just did, like verbatim. So what I would suggest doing is taking the second post preview that you picked up today, working on the first page yourself, front and back, check some answers, use this if you need to give you some guidance, and that'll get you ready for part 1 tomorrow. And then we'll do the second page of this one together on Thursday, and I'll have a second page for you to practice. But that would be the route.